Hello, can everyone hear me out there? Hello, hello, hi. Louder? Yeah, whatever. So I have a very fancy screen here that tells me that I need to start and will keep me on time, so let's get going. I'm here to talk to you today about 5+ reasons why you should map your network for teams. We'll have a little debate about the 5+ when we get to the end. The reason I went for 5+ is because as I went through it, there's definitely more than 5 places that you want to map your network for teams, or 5 reasons, but quite a few of them overlap with each other, so it felt a bit cheating to call each one out individually. So, you know, we'll see where we get to. My name is Ben. I work as a senior cloud architect for a company called Cloudway. Cloudway is headed up by this fine gentleman at the front here, based out of Europe, and we specialize in kind of all the different components of M365. Me in particular, I'm focused around teams and teams-orientated things. I'm an IT pro based out of the UK. You know, like a lot of people, I've got my legacy in OCS and Link and Skype and all those good things. I'm also, for my sins, the author of Cybex's MS700 Teams Administrator exam, and just recently taken over from Starley as a contributor to the Office 365 for IT Pros book, where I curate the Teams devices and calling chapter. So I'm going to start maybe in a bold move, being in America, with a bit of a UK in-joke. Does anybody know location, location, location? Don't know that that travels over here. So this is a TV show in the UK where you've got these two, Kirsty and Phil, very friendly kind of realtors, I guess you'd call them. And they go and meet people who, you know, they live in London, they make origami foxes for a living, and they've got £2 million to spend on buying a flat. And these two go and help them do it. And you're like, where on earth did you get all that cash from? Anyway, location, location, location. That's what we're here to talk about. Location is used in many, many places inside Teams. You know, like I say, we'll debate exactly how many. One of the most important ones, if you are doing calling in Teams, is for emergency calling, right? So location is used to help know where Teams should place an emergency call, because you need whoever is answering that to be near your location so they can come and help you. And there are also notification policies in Teams as well that, depending on where a user is, you might want to notify different people when someone rings an emergency number. The other place it can be used is to do with call routing. So stuff with direct routing, where you've got to do local media optimization, where you want to keep media traffic close to where your users are. Maybe you've got to contend with location-based routing because you need to deal with toll bypass restrictions. Maybe you need to do some form of bandwidth control where you've got sites that don't have enough bandwidth to support voice or video in the way that you want, and a little bit maybe to do with dial plans as well. It's also used and very helpful in monitoring the quality of your Teams voice deployment. So that's in CQD, and that's also in call analytics. And then there's part of it that you can use in preparation to help you with planning for your deployment, how you might expand your deployment. So we're going to go through each one of these in a little bit more detail. First one we're going to look at is emergency calling. So emergency calling, we need to make sure that we've got local responders answering the call. There's no point when a user dials out for help if it's someone answering in another country, another county, somewhere a long way away. There's 2 bits of terminology that come into play here. There's PSAP, which is the public safety answering point. That is, you know, the call center, contact center operated by whoever the emergency provider is. So ideally, you want to be sending your call to a local, to the user PSAP point. But you can also have something called an ECRC, which is an emergency call relay center, and that's when you don't necessarily know where the user's location is. You kind of have someone field the call and then route it to the correct place after they've determined the location of the user. If we're doing direct routing, we also need to know where we want to send that call, like which gateway do we want to send that to. If we're on calling plans, that's more, you know, Microsoft's problem on the calling plan side. If it's Operator Connect, that's the operator's issue. If it's direct routing, it's your issue to make sure you send that to a gateway that is appropriate for that call. Like I said, you can also do policies around emergency calling. So do we need to do anything else? Do we need to notify someone in the building that an emergency number has been dialed? Do we need to conference anybody in to that call with the emergency operator? And we can do that on silent. There's a whole bunch of other stuff we can do around that. And again, that might vary depending on the building or the location that the person is in who has placed the call, right? It's not a blanket company-wide behavior that we want. We need to be able to narrow it down. And the whole beauty of Teams is everybody can get access to what they need to wherever they need to be. So we have to have the policies in place and the setup in place to follow them around. So how do we deal with that in emergency calling? The first and arguably most important thing, and probably the one that doesn't get considered as much, is this notion of a trusted IP address, right? So given that we can have Teams users all over the place, and you might have overlapping subnets for different reasons, how do we know that the Teams client is on the inside of the network? That's what the trusted IP address is. It is the public IP address that Teams sees the client connecting from, and you associate that with your environment. So Teams, as the first check, says, does that IP match one that I've got registered? If it does, then I'm assuming that that user is inside the network somewhere, and we'll carry on with the processing here. So if you don't have that, it's not going to believe the user's internal, it's going to treat them as external. The next thing is something called LIS, Location Information Services. That is, if you are internal, whereabouts are you? This is to do with the address, the location, the place. So, you know, down to the street or beyond that if you want. And then lastly, we've got network settings. So that deals with which site and subnet are we in, so therefore which gateway do we need to talk to, or which other bit of equipment do we need to route the call to. So through this presentation, I do have a few kind of extra info slides. I won't dwell on them, but for, you know, if you want to look at stuff up afterwards, there's a whole bunch of extra information in there. The same with any links, and, you know, apologies, I'm aware that this deck is quite kind of old school PowerPoint information heavy, but that's because, as you'll see, this topic is quite information dense. So we're kind of covering it at a high to medium level, but hopefully there's more information in here that you can come back to and links to go read further if you want to later on. The one thing on here that's interesting is this is the behavior of placing an emergency call when you're on calling plans. And I don't know if anybody knows, but can you see that under United States? Let's try my fancy thing. No, it's not going to work. But you can dial 933 instead of dialing an emergency number, and that will read back to you and test the location that Teams sees from your users. So when you've done all your configuration and you want to check that things are okay, before you place a real call, you can do a test call to that 933. I was having a debate with Tom last night. He was like, well, why don't you just ring, you know, the normal 911 number, and in the UK, you can ring 999 and just explain you're a voice engineer, because that then proves that every single component is right. But 933 is kind of a softer option for, you're not quite sure if the location services are right, you're not quite sure if the addresses are correct. That will let you validate that piece of it before you can then do a full test. The trusted IP address, then, is the first bit that we're talking about. This information is shared with some of the other use cases that we're going to talk about later. You set it up inside TAC under locations and then network topology, and you can also do it through PowerShell using the -CS tenant trusted IP address family of commandlets. And the two useful bits of information that you need there are whatever the IP address is and what the mask bit is that goes with that IP address. So as we go through this, I'm going to start a collection bucket of all the information that we need or might want to be tracking for our location, right? So in our collection bucket for trusted IP, we've got an IPv4 address, the v4 range, the v6 address, and the v6 range. So let's, you know, park that and see how many things we get to by the time we're done. So next up is LIS. So LIS has its pedigree back in Skype for Business. That's, you know, and Link, that's where the term LIS comes from. One thing with LIS is it isn't shared with anything else. So, you know, you've got your address information and you populate that into LIS, but there are other places inside TAC and inside Teams where you also need to put address information as well, and they're separate. That's kind of one of the frustrating things with this, I guess. At the top layer of LIS, you have a civic address. So the civic address is your street address, and when you enter it into TAC, it gets validated. When it's been validated, you can't update or change it. You have to delete it and make a new one if you need to make any changes to that. An address can contain one or more location, but it's not mandatory. And a location can contain the things at the bottom there. So what access point the user is connecting to, what switch port they're going through, what network switch they're connected to, or what subnet they're connected to. The hierarchy, let's just get all of them up. The hierarchy is going to be that the Wi-Fi AP is identified by the BSSID. The switch port and the network switch is done through link layer discovery protocol if you've got that enabled, LLDP. And the network subnet is the broader, this range. The notion is that, maybe in a hotel or a building like this, the civic address would be the street address for this, so 8013 Quebec Street or whatever it was. And the location would be, if I'm on the Wi-Fi here, whatever that access point is, that would identify me as being in this vicinity, that I'm down in the conference floor, as opposed to, I'm on floor 3 or floor 4. That's why you have a little bit more granularity there. It might be that you don't necessarily need to do anything different about that, but again, bear in mind this is, to do with emergency services, and if we do place a call and we have to notify somebody else, it's going to be helpful to be kind of as specific as you can about where that problem is, where that user's making that call. So adding an address in TAC, we will try and do a little bit of a demo here. So inside TAC, under locations, we have emergency addresses. Now this is kind of snag number 1, right? So in PowerShell and in LIS, it's referred to as the civic address, but in TAC, it's referred to as your emergency address. Here, you'll see a list of all of the ones that you've got, and you see here that the status is validated. If I want to add a new address, I can come in here, and I can type in the name of my site, pick my country. It's in the UK. And then you've got the option to fill in your address, and this uses Azure Location Information Services. I forget the full name for that. The idea is that this is lovely and friendly, and you type it in, and it will auto-fill in the other information about exactly where that location is. I find this doesn't work for me in the UK, particularly. I tried addresses in London, in Newcastle, in Guildford, like all over the shop, and it wouldn't do it. And over here, this side of the water, it might be a little bit better, but I find that I have to say, I want to enter it manually, and then you go through, give house name, street number, blah, blah, blah. But the two really important bits here are the latitude and longitude, because that's the bit that narrows down exactly where you're going to be at. Now, you might wonder where on earth you're going to find that. The good news is that if you go to either of the two major mapping products, either Bing Maps or Google Maps, and search for wherever it is you want to add, when you right-click on the map, they've got an option down there to copy out your latitude and longitude, so you can paste that back into TAC. Once you've got your address created, you can select your address, and then here you can see those extra bits of information that we can add. Our port numbers, our subnets, our access points, our switches, and our ports. Now, the trick here is, remember, we can optionally have a location as well, right? So if I get carried away with myself and it's like, great, I want to start adding in my BSSIDs, which is not just the SSID of the broadcast network, but it's like the MAC address of the access point that the client is going to be connecting to. That's what the BSSID is. If I enter that here, that is just going to go against the address. If I want to add a specific location inside, and again, notice that it's called places in TAC, and it's locations in PowerShell and in documentation. If I, in my Banbury Castle, have got my west wing, I can click on there, and then I've got the same options to add ports, switches, subnets, et cetera, at that layer down. So this is how you can come in and you can build this stuff up. Again, you can configure this stuff through PowerShell. That's the family of commandlets there that you can use, so civic address, list location, subnet, AP, switch, port, etc. So, back to our collection bucket. What have we now got? So now we need to know our Wi-Fi BSSIDs. We need to know our network ports, our switch IDs, if we're going to be able to use that. We need our network subnet. We need to know our physical location, our physical address, but also our latitude and our longitude, right? So let's bring up the list we had before and pop those on the bottom. Next one, network settings. Network settings is shared with other services again, and there's a hierarchy to it, that you have a subnet is part of a site, and a site is part of a region. Generally, when you're dealing with network settings, it's the site level that we're interested in, right? You know, we associate items against sites, and as long as they match, the clients then, or you know, the devices then know that they're in the same location. For network settings, this is used to assign emergency calling policy and an emergency call routing policy. When you have a conflict, when you have policies that are applied to both users and sites, the site policy trumps the user policy, okay? Because it might be that you've got a user who roams around all sorts of different places, so you want something that applies most of the time to them, but when they're in a specific location, the site policy, if there is one, will override that. To set this up, we come again into TAC, and we go to network topology. And in network topology, we can add our sites in here. So if I pick on my site, again, it just happens to be named the same as my civic address site, but that kind of makes sense because I'm just having to put the same thing in twice. But in here, you can see I've got my subnets that are associated with this site, and up here, I've got the region that is associated with that site. So the regions aren't kind of curated or managed in their own little part of the UI, they're dealt with here. So if I want to change it, I can pick change, and if I want to add a new region, I can add it in here, and then change where that's associated. These don't bear any relationship to real regions, right? These can be anything you like. It just, you know, it makes sense that, you know, logically they would normally correlate with a geographical region. And then this here are the two policies that are associated with the site, right? So I've got my emergency calling policy and my emergency call routing policy. So I can say that this site, when a user is in 192.168.0.0/24, they're going to have that policy applied to them for emergency calls, okay? So far, so good? Cool. Okay. More stuff to add to our bucket. We've got our region name, our site name, our subnet ID, and our subnet mask going on top of everything that we had before. We're now getting into smaller fonts. But spoiler alert, we're going to get into some pretty small fonts by the time we're done. So next up is call routing, okay? So why do we care about the location when we're dealing with call routing? The two main things are local media optimization, to do with keeping traffic local to wherever a user is. And the second one is to do with toll bypass, usually for legal restrictions or legal reasons in a country that we need to make sure calls break out in a particular gateway or through a particular provider. The other thing we might want to do is restrict bandwidth usage. So has anybody played with CAC, call admission control, in the past, in the good old on-prem days? Location-based routing, not location-based routing, network roaming policies was added to Teams relatively recently, and it's a slightly friendlier version of CAC than we had in Skype. In Skype, CAC would just kind of kill part of the media, wouldn't let it go through. It failed, not even gracefully, it just failed. With network roaming policies, we can be a little bit cleverer about that. So, small pop quiz, might be a trick question, who knows. Media bypass. When direct routing first came out, right, all media had to go out to the Teams service and then back down to our gateway. Then we got a second version of it which allowed us to do media bypass. Does anybody know how location plays a part in media bypass? Anybody want to hazard a guess? No? Trick question, because it doesn't. What media bypass did is it includes the public IP address of the SBC in the candidate negotiations for media, right? Which is where you then end up with this nasty kind of hairpinning. You see the blue line from the internal users going up to the firewall and then back down to our gateway. That can cause problems. Some firewalls don't like that. Fortunately, the next iteration of improvements to direct routing and media flow was local media optimization. So local media optimization lets us properly keep the media direct from a local internal client to the internal interface on an SBC. It also lets us use proxy SBCs. So we can have a gateway on a site that doesn't have enough public IPs, or you don't want to open firewall ports on a local site. So you can proxy that connection behind an SBC in a data center that's kind of front-facing and doing all the stuff pointing to Teams. And you can allow the traffic to kind of route direct down to that. And that's where location comes in, because we need to know where an SBC is relative to where a user is, and whether they're allowed to communicate directly with each other, or whether we want to relay stuff back through the Teams services. How do we do that? Step one, trusted IP address. Are we on a network that classifies us as being an internal user? Great, so we can just reuse that same configuration that we had before from emergency calling. Network settings, what site is the client in? And then voice routes. What SBC do we want to use to send the call to it? And what site is that SBC in? So we can marry up that the user and the SBC are in the same location. If that site matches, then we know they're close to each other and they can route media direct to each other. First of all, we need to make sure that our sites are configured. So that's the same stuff that we did before. And then this time for our SBC, we go into our SBC configuration, which is under voice and direct routing. Then we pick our SBC, and under settings and editing our SBC, down here, where are we? There. We've got our gateway site ID. So that's just a pick list of all of the sites that we've created in our tenant so far, and now we can say that this gateway belongs to that site. And if we were doing proxy SBCs, we've got this box down here, which I don't have any other SBCs configured in the tenant, but in here you can say this gateway is being proxied through another one, right? So it's important to remember when you're using proxy SBCs that even though the proxy SBC is the one that's Teams facing and visible on the internet to anything that needs to see it, these gateways that are behind that still need to be registered in TAC. You still have to have them in there, even though they're not going to be talking directly to Teams themselves. So, our collection bucket. Now we need to have the FQDN for our SBC. We need to have the bypass mode for our SBC. Actually, I think I skipped over that. Let me show you the SBC here. So this is whether we've got media bypass enabled, and this is what mode we want to apply bypass in. Do we want to not do bypass, in which case, well, we're not configuring it, so we wouldn't pick that. Do we want to always enable bypass? So that means if we've got an internal site that has good connectivity to other sites out on the network, if we want a user in site B to still be able to route to the internal interface of this SBC on site A, we would say we always want to allow it to go to the internal interface. But if we've got a site where we only ever want local users on that local site to be able to send calls to it, then we would pick only for local users in the bottom option there. And that means that it's contained to only people like actually close to it. Okay, so add them to our list. Next up is location-based routing, all right? So normally in a voice deployment, you aim to do something called least cost routing, which is where we've got a user over in the UK and they're placing a call to the US. We've got the dotted line is an internal IP call going to the gateway that is local to wherever the destination number is, and then we break out onto the PSTN and we only pay for that short hop of a call, right? But there are some reasons that we need to do what you might want to call most cost routing, where we've got, in India in particular, this is common, that you've got a user in India has to send the call to a gateway in India, and then the long portion of that call has to go out over the PSTN to whatever the destination is. So we're going the long and expensive route round, but that's regulatory requirements so that the telcos can take their money, etc. So how do we do location-based routing? You can set it up in the user's calling policy. There's an option in there for that. So the very one down at the bottom here, prevent toll bypass and send calls through the PSTN. That's the setting that means that we're enabling LBR for that calling policy. We do it at the site level as well. So you see just under network region where I've got UK, there's a little toggle box there for location-based routing. That has to be set to on. And then we also do it on our gateways, right? So on our SBCs, in the same way that we had the settings for media bypass, down at the bottom there, we've got a toggle for location-based routing to be either on or off, and then we've got a user override toggle for LBR as well. The user override means if we've got a user who has location-based routing enabled in their calling policy, but they're not inside the network, they're outside the network, do we still want to allow them to route a call to this SBC to place it out onto the PSTN? If you don't have that on, then that user might not be able to place the call. It depends what other gateways they have configured in their PSTN usages. But if we do need them to be able to make the call, we turn that on, and then they can send the call through that gateway. LBR is super duper complicated. Quite a lot of the things I'm covering here, like E911, media bypass, LBR, are all things that you could spend an hour on going super deep into just those if you need to. I have put a little bit of an FAQ. Like I said, this is kind of one of those slides that's maybe a bit more use after the session. But there's a whole bunch of scenarios that, with LBR, it seems really simple on the surface. Like, make sure a user sends a call to a particular location, but what happens when a user's receiving a call that's coming in from a gateway, and maybe that gateway the calls come in on isn't local to the user or isn't in the right region for the user? Or what if the person is signed in on multiple devices, right? That's what Teams lets us do, be on our mobile, be on the device in the meeting room, be somewhere else. What happens to LBR when we've got multiple endpoints? Well, fortunately for this, it does kind of applies the rules against each endpoint in turn to determine which endpoints will ring. So it might be that a user who's signed in on multiple devices will only actually have one of them ring because of LBR restrictions. How does it decide if it's going to be okay to place the call? It looks at if the Teams calling policy has LBR enabled. Is the endpoint in the site where the user's signed in covered by LBR? Because it might be that the user isn't normally, but where they happen to be is covered by it. And is the SBC itself covered by LBR? And then what about other calling scenarios, right? What happens if a user transfers a call? So it wasn't an LBR-enabled user, and they're transferring it to someone else who is an LBR-enabled user. Is that going to be okay? Does that need to fail? Does that need to work? Or conferencing or group calling. You're in a conference call, you've invited a PSTN number in, then you invite a user who's got LBR enabled. There's a whole heap of kind of ifs, buts, else, maybes about where you want to, in what way you want to make LBR work. And then what happens if the call can't complete? If LBR determines that the call is not okay, it's not allowed to succeed, there's reasons that it can't connect, what happens? If it's an outbound call, we get a graceful failure on the client. The Teams client will pop a message and saying, company calling restrictions don't allow you to make this call. Not too bad. If it's an inbound call, if there's no endpoints that are able to answer it, then it will obey whatever the user's unanswered call settings are. So that might be that it'll go to voicemail. It might be that it does, something else if it got configured, but voicemail would be the default there. So what do we need for LBR? Well, we need to know our SBCs again, and we need to know the override behavior that we want to have for that site or for that SBC. So we pop them on our list. Little bit of a, doesn't quite fit, but it's worth mentioning anyway. It's not strictly a location as far as Teams is concerned in the same way that the others have been subnets and addresses and all that sort of stuff. But it's worth noting that dial plans are based on the usage location of a user, right? So the dial plan is the thing that converts the number that the user enters into the number that is actually dialed, into the E164 number that is sent to the direct routing gateway or to Microsoft for calling plans or to Operator Connect. That comes from the usage location attribute against the user, and that is a 2-letter ISO country code, and it's also used to determine what service availability there is. So if you're, got a user who's based in the UK, but their usage location is set to something else, they wouldn't be able to have potentially calling plans assigned to them as a license, because that doesn't match with a location where they're allowed. Okay, so roaming policies. Roaming policies are used to limit the bandwidth that the client can use when they're making video calls from a location. Fairly simple to set up. It uses the same network settings that we've dealt with before. So where we have our LBR enabled and our 2 emergency policies, the one in the top right there is our network roaming policy. We go and associate that with our site, and our site has our subnets. So again, when our user's in a subnet that matches the site, we get that policy applied to us. The roaming policy itself, you give it a name, a description, and then effectively it overrides the 2 settings that are in the user's native policies, right? Whether they're allowed to do IP video or not, and what the maximum bandwidth for media is when they're making and receiving a call. So you can tune that to either turn it off or restrict it down so the client will not go up to full 1080p, 60 frames, potentially depending on what's going on. Again, you can do it through PowerShell if you want to, so that's the -CS Teams network roaming policy. Incidentally here, all of these, that's new, get, set, that's what I mean with the verb and then the family of the commandlets there. Hi.
You said that media bit rate, what is the experience that the end user receives? Do they get a banner saying, hey, we can't give you the full experience, therefore we're downgrading, or do they just experience what data there?
Yeah, so the question is what's the experience for an end user when that's set? I believe they don't get a notification. I think it's just the client will, you know how the client kind of figures out how much bandwidth it's got, and then it decides what codec it's using, what frame rate it's sending, and what resolution it's sending. It will just restrict that so it doesn't breach whatever the figure there is. Okay. I didn't get to throw a box at you. I've got a box now for throwing at people. Call quality. How am I doing? Everyone sticking with me? Yeah? Cool. Where do we need to use location? We use it in 2 places. First one is in CQD, which is the call quality dashboard, and the second one is in call analytics. Now, why do we care about the location when we're doing, reporting or proactive maintenance on our network and having a look at what the quality is like? Why do we care about our location in that case? The reason is that Teams lets you make calls from many, many different locations, but that doesn't mean that you're always going to be on a good network with a good device, with a good connection, and that you're going to have a good experience, right? So location is really important because it allows you to differentiate between calls that should have been good and weren't, and calls that we had no control over. This was a little diagram that it was actually based on one that I drew up for a customer around Skype for Business call quality. So this used to have like front-end servers and edge servers and all sorts of other stuff. But this was just something that they were having a hard time wrapping their heads around. Well, why can't we have amazing call quality 100% of the time? So just trying to illustrate that, over on the right-hand side, we've got our user with their company mobile phone, with their company laptop, with a company headset, connecting to a company network. Those items you can control, and that's going to be, as good an experience as you can get, because you've got the ability to put, quas on your network, make sure that there's enough memory and the processor's all right and everything's patched and we're all good on the desktop side. The Wi-Fi, still got to, we can influence that. We can make the Wi-Fi as good as we can, but hey, at the end of the day, it's Wi-Fi, right? So it might be someone's turned the microwave on next door, and that's still going to then interfere with what's happening. The other stuff we can control when we're dealing with the Teams media is the connection to the WAN, the connection out to the internet. maybe we've got an SBC and a connection to an upstream PSTN provider. We can influence that, but that ultimately the quality is going to be down to whoever the provider is upstream. And then we've got a home user on the left-hand side, right? So again, we might be controlling the laptop. It might be a company-issued device, but we probably don't have control over their home Wi-Fi. We probably don't have control over whoever their home broadband provider is, and we certainly don't have control over their internet connection from home. So that's why you're always going to see stuff in CQD where we're not getting 100% good calls all of the time. We're going to see different grades of call quality. Just to kind of illustrate that, this is a little kind of infographic that I stole from Link Conference 2014, actually, was the first time I saw this. And I thought this was really useful just in terms of helping set expectations with users. And it applied to Skype, it applies to Teams even more so, that just because you can make a call from Starbucks or from the Marriott hotel lobby, that doesn't mean that you should, because you might not have a good quality experience doing that. So even though we've done all of the things we can behind the scenes to make sure everything's working, lined up, and great, doesn't mean it's going to be okay. And so you kind of have this gradient of like, well, if you're doing something super important, make sure you're in the office if you're allowed to, with all your approved gear. And if it's something that you just maybe have to sit on, you're not too bothered, you don't have to contribute, then we don't really care where you are. But back to CQD, that might still in our CQD show as being a call that was bad or poor or might need investigation. So, CQD anyway. How many people have a regular review of their CQD? Nobody, one person.
Only because we just switched from pairwise to SIP, and we have Jen or Silver constantly looking at.
Yeah. So how many people have never looked at CQD? Okay. So unfortunately with CQD, as much as I love CQD and I enjoy talking about it, I don't have access to a CQD environment that I can show you at the moment. So I'm a few months new into a different job, so I don't have any customers that I can kind of sneakily log into. And one of the problems with, anyone familiar with the CIE demo environments that you can spin up from Microsoft, there's no CQD data inside them. So as much as it's great that you can build gateways and you can build routes and you can build all the stuff that you want to mess on with it, you can go and look at CQD, but it's totally pointless because there's nothing in it. So hopefully that's something that maybe we'll get a little bit of a test bed to have a look at. But if you haven't looked at CQD, you're missing out, right? CQD is kind of information heaven in terms of all the data that you might possibly want to find from a call is going to be there inside CQD. And you can get all these kind of cool trends and looking at what the average % of poor call quality was over a particular time period. You can track that, and the reason location is important here is you can track that against managed networks and unmanaged networks, right? So managed network is one that is mine. It's my company's network, and that's where I know that I should have a better experience than an unmanaged network. And you can, in these reports, build them up and compare and contrast them. So like show me the number of good calls or percentage of good calls on unmanaged versus the percentage on managed, right? That's where location is really important in this. In terms of what you stick into CQD, it is done through something called building data, okay? So if you haven't played with CQD, go and play with it. And if you go and play with it, try and get as much data as you can to put into that building data file. So the left-hand column in the table here is the headers of the data that you should be putting in there. The middle column, the include, some of them are optional, some of them are recommended. You'll see there's sort of three at the bottom there: Inside Corp, Express Routes, and VPN. And Inside Corp and Express Routes are mandatory. So even if you get your address, you get your subnets, got all the other stuff, you need to make sure that you still include whether it's on an Express Route connection or it's inside corporate. The right-hand column there shows, because some of the names aren't necessarily that obvious, right? So network IP, great, that's our IP range, and that marries up with the network range, so it's a /24 network. The network name can be anything you like, but it kind of makes sense to make it a concatenation of, generally kind of site and then region and then, location. Again, this is entirely independent from the other places that we've put sites and locations and addresses in, so you can kind of call them different things if you want to. Building name, call it what you like. Building type, office type, maybe you want to differentiate between something that's technically on a company network, but maybe it's a Regus, it's not a wholly owned building that you have full control over, but it's still something that you can kind of influence to some degree. And then the other stuff is the fairly standard, city, zip, country, state. The VPN connection as well is helpful because, again, with CQD trending call quality, ideally you shouldn't be putting calls in Teams over a VPN if you can help it, right? Because that's, you're adding extra overhead to the processing that's required for that call to get from A to B. So having that VPN flag, again, means in CQD you can build reports to differentiate between stuff that was on a VPN and stuff that's not on a VPN, and it can help you with troubleshooting. Along those lines, also, there's a couple of other useful reports in there. There's an update to the QER Power BI files that I haven't been able to play with yet, but there's some really neat reports in there that let you kind of go and look at users to see what specific users have been having specific problems, or you can see what's your UDP versus TCP usage, right? So if you've got locations where you've got high TCP usage, all of Teams media should ideally be happening on UDP. So it means where you've got sites where it's high TCP, something is blocking the ports that you should have open to allow the traffic to flow freely. So that's what CQD is really good at. And it's easy for me to say, but if you've got Teams voice deployed or a lot of Teams calling going on, so Teams conferences or Teams to Teams calls even, you should be doing kind of at least monthly reviews of CQD just to give you a trend across what's happening, so you can do a baseline. The other thing that's quite cool is that this building data file, you produce it as either a TSV or a CSV, so tab separated or comma separated. You don't put the headers in there, so it just starts with the first line as the first line of your data, and you upload it directly into CQD at cqd.teams.microsoft.com. There's a little cog in the corner, and you upload your building data file. Once you've done that, after about 24 hours, usually slightly quicker, you'll be able to start seeing that building information in the reports. There is a report that you can run that will show you the most common sites that don't have any location associated with them. So even if you think you've mapped 50%, 60%, 90% of your network, you can then run that other report to show you what other subnets don't have location information, so you can then go and figure out where that is, where, what site it is, and add the location in. Another little bonus tidbit, when you're looking at reports inside CQD, you'll see two fields generally for the same bit of information. You'll see a first something and a second something. So like a first device type or first network type and a second network type. Does anybody know what the difference between the first and second types is? So when you do filtering, you would always do filtering and build your reports around the second type. It's because when they've built this, whatever it is they're doing in their big data warehouse, anything that was from the server goes into the first column, and anything that was to do with the client goes into the secondary column. So in Teams, we don't, the servers aren't ours, they're not our thing. So our bits of information that we're concerned about is always on the secondary side, because that's always our client or our endpoint or our users' equipment. So just bear that in mind if you're having a look through. It's not necessarily obvious. Another little bonus extra, not strictly to do with location. Has anybody come across endpoint mapping in CQD? I'm guessing probably not, given not many people have looked at CQD. This is something that I found actually when I was just going through my prep for this. Sally, have you come across this at all? No? So there's another upload that you can do in your CQD. So it's not just your building and your location, but you can upload extra information about your endpoint devices, right? So again, this is super helpful if you're looking at building a report to say, show me what this kind of device or this kind of meeting room or this kind of setup, how's that performing versus others. So the same way that you build your little CSV, TSV for building data, you can do the same thing for endpoint mapping. You put your endpoint name in, not fully qualified, that has to be unique, and that's what it will then use to pull in this extra information into the reports that you can then see and trend across. So that can be really helpful, particularly for, say, Teams meeting room deployments, where you can put in the name, who makes it, what the model was, what type of device was an MTR on Android, on Windows. Maybe it was a collab space type of room. We've got 3 kind of generic fields that we can use in any way we want. So again, we can then build a report to say, great, show me how all my MTRs on Android are performing across the organization. And hopefully, you might not have any MTR OAs that aren't in the location. So hopefully you can, merge those together. It is case sensitive, and they have to be unique based on that, the endpoint name. Pat, my timing screen is telling me that I'm 59 minutes. I'm assuming I've got 15 left, right? Yeah, just keep going, okay. String values only, less than 64 characters. But this is one of those kind of neat things that's pretty cool if you need to be doing reporting and you've got different meeting rooms, so worth knowing about. Call analytics. So we talked about CQD, now we've got call analytics. So call analytics is the opposite way up to CQD. So CQD is supposed to be big picture, show me my trends, show me what's going on, and then I can narrow that down by our location to see what offices, what buildings, what floors might be having problems. Call analytics is the other way around, where you've got a user has a problem and we want to help troubleshoot that. We can import the same data file as we do for CQD into TAC to then apply the same location information against call analytics. I guess mildly frustrating that literally it is the same file, so exactly the same as you put into CQD, you put in here. You just have to do this in a different location. So to do this, you have to pop it into TAC under reporting labels. So in here, under, where are we? It's reporting and analytics, I think. Reporting labels. It's literally the only thing you have here. There's nothing else to configure. You just pick, upload. You can download a template. If you're not quite sure on the formatting of that CSV, TSV, you can pull it down there and modify it and stick it back. Upload that, and then it will apply against analytics for you. Okay, so our collection bucket. What do we need? Well, there's a whole heap of stuff this time. So IP, network range, some of that does overlap. So if we look at what we've already got in there, we don't necessarily need to add all of these new bits of information, but there's quite a few extra things there, stuff like inside corp, express route, VPN, what type, etc. Planning. Anybody played with Network Planner inside TAC? One? Okay. So Planner is something that you use to model the capacity of your network. And it's based around personas. So you create personas that say, these users are going to roughly do these kinds of things. They're going to be on Teams meetings, or they're going to make PSTN calls, or they're going to do audio calls, or they're going to do desktop sharing. And you build up a kind of picture of your network and how it interconnects with each other. But again, this isn't linked to anything else. So even though we've got addresses, we've got sites, we've got some element of whether they're on VPN or how the WAN's configured, the stuff that you put in Planner is entirely independent from any of the rest of that. The Planner itself, I'll pop that open, is found under Planning and then Network Planner. And you create a plan, and you can have more than one plan because you might be using this to model maybe an expansion or an acquisition or a significant change, and you want to kind of understand what the impact on your network capacity is going to be. If you go into your plan, you can add your network sites. You can, if you want to, add an address against them, although I'm not entirely sure why when this is just modeling and doesn't get used anywhere else. You would choose to, but you could if you felt the need. But then you put in your subnets, whether you're on express route, whether you're on the WAN. If you're not on the WAN, you pick how you are, you've got to have internet breakout for that site to be able to communicate. If it is on the WAN, then it might be that we break out through another site. if it's remote, and then we pick what site we break out for the internet. So you build up this picture of what your network looks like, and you can specify the capacity of all of these different links. When you've done that, you can then come and run a report, and you can see what the expected impact might be against your changes. When you first generate a report, it will ask you to allocate your personas against the total number of users. So when I built this, I said I've got 10 users, and then I've said 8 of them are my office worker persona, and 2 of them are my remote worker persona, okay? So, you know, it kind of beats messing on with spreadsheets. If anybody had to do that back in the day and doing kind of fairly complex calculations, you can come in here and you can do it in Planner. Now, you can normally only configure Planner through TAC. However, Alexander Homset, who also works at Cloudway, figured out a way that if you go and look at the calls that are happening to the TAC web service when you're going and adding these things in, that actually you can replicate those and automate it through some PowerShell scripting. So you can build yourself a little Excel file, a little CSV, download the script from Alexander's site, and then you have to grab an authentication token from the browser session that you're in, put that into the PowerShell script, and then the PowerShell script will go and kind of populate the network planner out for you. Because you can imagine if you've got quite a large deployment, you know, there's quite a lot of clicking around to have to do that. So, collection bucket. We've got a whole heap of other stuff again that we might want to use for our our data collection, number of users, PSTN type, whether it's ingress, express route, et cetera, but there's only a handful that are independent of what we've gathered already. So how might we go about gathering this information? Because this is a lot of data that potentially we need to have about our network, right? Well, step one, networking team's going to know all of this, right? Right? Just go and get a list of the subnets off them. And they'll tell us where everything is. That's all cool. No? No, okay. You got to talk to the networking team, regardless of if they've got the answers or not. They're responsible for the network. And you know, you remember mostly we're dealing with subnets, and then we're dealing with switch ports and access ports. It's the networking team that's going to have that information for you. You've got to engage with them to get as much as you can. Facilities. Facilities are going to be the ones that will tell you the specific addresses, right? They're probably not going to tell you the latitude and longitude. You're probably going to have to figure that out for yourself if it doesn't show up automatically when you enter it in there. But maybe you can start pulling some of that data from other systems, right? You know, just what do people use for DHCP these days? Do you still use Active Directory for doing DHCP? Do you use something like InfoBlocks? Nothing. No one uses DHCP. You're all static. Wow, okay. If you're using Windows for DHCP, there was a script. It was from 2018, written by Martin Renas, called CQD Tools that you can go and hopefully download. That will kind of go and crawl through your AD sites and services and pull out, you know, what DHCP servers you've got that are Windows, and you can pull out the scopes from them. Hopefully you can get some of that configuration from firewalls and switches. You know, maybe you can have a poke around in that. Unfortunately, I don't have a magic answer for you for any of the rest of this. It's just a little bit of hard graft. But how do we organize and store that data? Again, I don't have any perfect answers for you. I was hoping that, you know, I was going to kind of end up with some sort of nice SharePoint list that we could then do a script and pull stuff out of. But, you know, as you see when we're going through that collection bucket, you're ending up with so many different things, and actually really you probably need to have some sort of a relational database where you've got, you know, one-to-many of your sites and subnets and buildings and all that sort of stuff. But I would suggest that actually you would be breaking this up into different components, right? So the stuff to do with emergency calling and LBR and LMO might be independent from the data that we're using for CQD and call analytics and possibly network planner. Maybe we group those things into one bucket and we group the other stuff into another one. Again, something that I'm kind of working on, so, you know, no promises, but maybe this time next year I'll be back talking about how you can automate your location processing in Microsoft Teams. Got an idea that you can kind of store all that stuff and then run some scripts, and there are independent scripts out there that will pull out CQD data from lists and import that and generate the right files. If I was, having to collect the data, this is kind of the main takeaways of out of that massive, massive list of stuff. These are the key ones that you want to be looking at. So, site name, network mask, the public IPs, because remember that was one of the most important things. The physical location data there, the building names, the rough numbers of users. Do we want to use proxy SBCs, etc.? So that list, again, it's more for having a look after. That would be kind of the main bits of information that I would start by gathering and then refine that depending on what your particular use cases are. So we're nearly there. We're nearly there. My screen's working. I've got 4 minutes to get through this. So the main takeaways from this is, hopefully you can appreciate location is really, really critical for emergency calling, because emergency calling, people only do it in an emergency, and as well as it's all very well you can say just use your mobile phone, don't use the Teams service, you probably still need to make sure that the Teams service is okay, because you don't want to be having to deal with the fallout from the one time someone needed it, it didn't work right. So just make sure that, that emergency, if you're in America, over here in particular, that E911 is configured properly and that the dynamic address stuff is right. Location is really, really helpful for CQD. Have I sold anybody on CQD? Is anybody going to go have a look at that? Yeah, at least one. Cool. And then if you're doing direct routing, LMO and LBR, hopefully you're not having to deal with LBR, because you'll know if you need to, if you've got India and UAE and other locations where that's critical. If you have to deal with them, there's some really great articles that run through the breakdown of all those different components and how they interact with each other. The other thing, remember the external IPs, that's that first checkpoint. If we fail at that, we don't bother processing any of the rest of it, so make sure we've got our external IPs correct. And probably a soft place to start is by starting to gather the information that CQD needs, because that gives you quite a chunk of the data that you need for the rest of it, and go ahead and start building that out into an Excel file or a SharePoint list somewhere. But make sure that you have some form of a process to review it and update it, because there's no point doing it once, then in 6 months' time it's out of date and you don't know where to start. So in the same way that you've got a leave as start as user process, do something with your networking team so that they notify you when they're making networking changes, and you can then appropriately update the right stuff into Teams. So, recap of all of the different types of location, what you use them for, where you use them, and how you configure them. So where did I land on 5+? Do you think 5+ was a valid title for this? I think we had a few there, 1 or 2 sort of overlap with each other. I'm happy with 5+. It's a bit of a cop-out, but I'm sticking with it. Come on, buzz on. There we go. And then lastly, further reading. So there's some really good, no, I've had like 5 button presses. Super good information on TechNet, well, docs.microsoft.com, sorry, I should say these days. When you look at the docs page and it says like time to read, estimated 6 minutes. Some of these are like 20 minutes, 30 minutes, 40 minutes, and I guarantee you, because I was rereading them on the plane on the way over here, your eyes just like whoosh. So just take them in chunks and go through it. You'll be fine. Again, hopefully after this you can grab them, go have a look at some of these links, and that brings me to the end. Any questions before we say goodbye? Hi.
So we're migrating tenants.
Can I throw a thing?
So, test. Hello? There we go. So we're migrating tenants from GCC to commercial.
Okay.
And my understanding is that a lot of that doesn't just port over. Is there a method, a PowerShell or whatnot, to get the data that might be in there that we have not maintained lists for?
Yeah, so if you put it in there, all those PowerShell commandlets, you can do a get, whatever it is, and you'll dump out whatever, and then you might need to do a little bit of formatting and a little bit of playing, but then you can do a new dash, feed in what you got out of your get. So hopefully that will see you through. But I mean, you've got all of this in a source somewhere, so you just take it all back from source, right?
Right. Thank you.
Okay. Any more for any more? Cool. Well, on that note, thank you very much, and thank you to all of the Platinum sponsors for for hosting us all on these 2 days. Been good fun for me, hopefully good fun for you. No one fell asleep, doing okay, I think. So thank you very much.